Okay, we're recording and it looks like everything's going. Okay, welcome to Math 219. I am Clark Bray. I'm going to be your instructor for this summer term 1. And I have a bunch of introductory comments that I want to make that I feel are necessary to make at the start of every course. So here we go. Okay, so very first thing, this is a quickie, but if you're thinking about a math major, please come talk to me. Not important, but I think it's just a good idea to check in with, make sure that, given what your background is, make sure that you're making good course choices. It's an easy opportunity, so why not? Okay. All right. Okay, so real quick then, I want to refer you to the class website. Here is where you will find the class website right there. If you are listening to this recording as prompted by an email from me that I hopefully, presumably, just sent you, then I'll bet you I probably include this in the email itself. So hopefully I did. If not, then you can type this in. Okay. All right. Okay. So there's a lot of stuff on that website, and we're going to kind of walk through that over the next little bit here. But make sure to read all of that very important information. It's tremendously important information, not just about how the course is organized, but about what the course fundamentally is and how you should think about it and how you should approach it. So tremendously important, and please consider that to be your first assignment in this course. It would be to read that website and the links that all the links that are attached to it. Okay. All right. Okay. So let's dive in on that. First of all, I guess I'll show you the site itself. Here it is. Just structurally, I'll point out that there's, aside from a little text up here, there's various links down here. You want to click around on those, make sure you see everything that is available there. Also, notice in big, bold font, there is a course website. This is stuff about this course that is more sort of course-wide in some sense, as opposed to just my individual section. Now, the distinction is fairly irrelevant in this summer term 1 because I'm the only instructor, right? And so, but it's just easier to continue from the structure of websites that I have from the semesters to leave it in this sort of approximate format. Okay, all right. So while we're here on the course website, I will point out the first big item on our outline here is the content syllabus. So back to the site. Here it is. You see right there, first link, content syllabus. I click on that, and what we have here is basically a complete list of everything you need to learn in this course and all of the what you need to know going into the course, stuff like that. So make sure to read all this stuff here. I'm not going to read all of the verbiage on all these sites. Take way too long, right? But do make sure to read all that stuff. And I'm just going to point out some broad strokes. You'll notice that there are a bunch of book sections and titles enumerated here. This is the indication of, from this textbook, the Colley 4th edition, Vector Calculus, which sections are we going to be discussing and are, part of the material for the course. Okay, you're also going to notice there's a list of exercises here in this column. So when we finish, for example, when we finish section 1.4 on the cross product, at that time, I will assign the homework exercises for that section, and you don't do all of them that are in the book. That would be too much. But the ones that are enumerated here, the ones that are listed on the content syllabus for that given section, these are the exercises that are assigned. Okay, and we'll talk more about how that logistically works soon. Okay. All right. Now, the couple more columns that you're going to notice here, there's one called excluded material. Let's start with this first because it's the bigger column, frankly. There are some things that are in the book that are not part of the course. Our textbook, as much as I like it, I actually really do like this textbook quite well. But it is really technically at kind of a higher cut through this material than is the intention of Math 219. So certain things, like there's a bunch of stuff in section 1.4 in this addendum called Proofs of Cross-Product Properties, and it's just not really what this course is about. Now, you are welcome to look at that. I'd be thrilled if y'all were, motivated enough to, dig deep. In fact, this stuff I'll point out might even help you learn the ideas that are fair game for Math 219. But you don't have to. There's no expectation that you will. So it's highly optional. I think would be a fair statement. Okay, so be on the lookout as we're going through the course. You'll notice there's a lot of stuff in here that is excluded from the course, thus the title. Okay, now you can probably guess what included material is. This is stuff that is not in the book, but that is part of the course. So the first example you're going to notice here in section 2.5. The book does not have any discussion on what I'm going to loosely call second derivative chain rule. And exactly what that is, we'll talk about when we get to the appropriate time. It's not important here. But it's, I think, very important in many applications. This is not an abstract mathematician's sort of topic. This is really important in physics and engineering. And the book doesn't have any discussion of it. So anyway, it will be fair game. It will be discussed in the lectures. And so heads up on that. Okay. All right. And so this goes all the way through the course. And you'll notice some of these sections. So, for example, section 5.5, it turns out that's an enormous section. It covers a tremendous amount of material. And it takes us about 3 days to get through it. So I've broken up the assigned homework exercises into 3 parts. And so, for example, if I assign, parts 1 and 2, and I'll refer to these exercises here. Okay. All right. So that's the content syllabus. And let's see here then, moving along in our little outline here. Let's talk about the class schedule. The class schedule you're going to find on the class website, or my section website. So this stuff is specific just to my section. Again, I am the only section, but nevertheless, for organizational reasons, this makes sense. Okay, let's see here. So we are going to talk about the class schedule. Here it is. Again, one of the first links. And here we go. So several things to notice. Again, a bunch of text here. Make sure to read all of that. Very important to make sure you read the devil's in the details. So don't skip out on that. But here's the broad strokes again of how this is organized. You see I have it organized roughly by weeks. That's just to kind of help us keep track of where we are. So in a given week, for example, this week right here, on our 5th class meeting, which will be Tuesday, May 21st, this is what I'm going to call my target for where we will be in the course. Namely, I am expecting on that Tuesday to be in my lecture notes through Chapter 2, page 14. We may or may not actually do that. We might be behind schedule. We might be ahead of schedule. Anything could happen. And the faster we can get through the early material in this course, the better, because y'all may have heard the rumors, but chapters 6 and 7 are the most challenging material in the course. There's a tremendous amount to say. It's important that students have time to sort of digest these ideas, and so the more time we can leave for this, the better. Okay. All right, so anyway, these are, again, my targets. What actually happens, and this is largely a tool for me to keep track of where we are, but also very useful for you if you want to, reminders of where we were at, certain points in the course. You can refer to these columns right here, and those will be updated as we go along. Okay, so concerning the homework, homework 1, on our first day of class, we will finish certain sections, specifically certain sections from the content syllabus that we were recently looking at. And when we finish a section, or when we get close enough to finish with a section, then I will assign that section. And again, as previously noted, that means that those exercises listed on the content syllabus will be part of that homework assignment for that date. Okay, so again, on this date, first day of class, whatever we finish will make up homework 1. Those sections will be listed here, and that will be due on that date right there. Now, real quick, I want to talk about the turnaround time on the homework. This is a tight schedule for homeworks. The idea is as follows. The idea is, we learn material, let's say, again, just to get started, you'll learn some material on this Wednesday. And I think it's a really good idea to get started immediately. Same day. You should be starting the exercises, get going that same day. Now, I fully recognize you might have trouble with some of those exercises. And by the time you identify that you had trouble with those exercises, it might be evening. The office hours are over. And I don't want y'all to be stranded high and dry, unable to turn those in. So the idea then is that I give you Thursday to seek help on those exercises. Right? Whichever ones you had trouble with, whichever ones you couldn't knock out immediately, on your own on Wednesday. So you're going to want to make a plan for where you're going to get help. You'll have options. I'll have office hours. I'm expecting we'll have TA office hours as well, to be determined. So you get the help you need. Maybe you talk to some friends, right? I hope y'all will group up and make study groups and trade ideas, that kind of thing. I'll talk about that later. Then now I don't want y'all to have a time pressure on this second day to not only make sure you figure out how to do those exercises you had trouble with, but also to get them all written up and then try to make some sort of a deadline on that same day. And that's why I make the due date the third day, right? So thus this Friday due date for the stuff that is assigned on Wednesday. So I think if you stick to a schedule, and if you stick to this pattern of, do as much as you can on the first day, seek help, and make sure you understand everything thoroughly on the second day, and then, wrap it up and get it submitted on the third day, then I think that'll be plenty of time to get it done. And it's very important that we have a tight schedule like this because summer classes move so fast. Notice there's only 6 weeks, really. That's slightly less, actually. So we can't have homework be weekly. That would be way too slow, given the blinding pace that this course will go at. So I do this 2-day sort of turnaround time. So, related note, notice that means that on any given day, you're actually going to have 3 homework assignments kind of up in the air. So let's talk about this Friday here, right? On the third day of class, this Friday, May 17th. You're going to be turning in homework 1 on that day. You're going to be seeking help for the ones you couldn't do from Thursday's assignment. And you're also going to be taking your first crack at the Friday assignment. In other words, the ones from that class day. So there's an organizational challenge here, and this is something that you have to work out your own system for, but make sure you have a reliable system for making sure that every class day that you wrap up the homework that was assigned 2 days previously, that you finish and get all the help that you need so that you can finish the one from 1 day prior, and that you start the one assigned on that same day. So, again, work out for yourselves, how you're going to best keep track of those details. Okay, all righty. Now, last thing on this page, I'll point out while we're here that I also have, well, maybe this isn't the last thing, but this is, I think, a really useful, this column here called Comments and Reminders. There are various little things that need to get pointed out through the course. So, for example, on this day right here, this day right here, that is a mere 1 week before the first exam, right? Our first exam right here on Tuesday, May 28th. So this is just a kind of a heads up. This comment right here is that, it's coming up, right? I mean, this class moves really, really fast. Summer classes they're just blinding pace. Super duper fast. So little bits of advice, little heads ups, that kind of thing. So I encourage you to always keep an eye as you go through, as time passes, as the days pass. Always keep an eye for when there's a comment here that can be helpful. Okay. All right, so let's see here. Back to the outline. And let's see here. Let's talk about class grades. Okay, so very important topic. And again, everything you need to know is on the website. We will start on the course website here, where there are some, again, sort of broad, course-wide type stuff. Again, all of this is relevant to our class. And so roughly speaking, we're going to be doing a weighted average to determine your course. Weighted average on the 4-point scale, and just to make sure everybody's clear on what I mean by the 4-point scale, that's where, A is 4.0, A minus is 3.7, etc. Right? This is exactly what you think it is. And all items from the course will be converted to the 4-point scale, and then we will do a weighted average of those 4-point scale grades for all the weighted average, for all the graded items. So notice the midterms are the main thing. That's going to be the primary assessment of your proficiency, and they have to add up to 90%. That's been standard for many years at this point in multivariable anyway. But there are a few other items that are also significant. 10% is not nothing, right? That 10% is can make quite a difference, and that'll be other items, and we'll talk about the specifics of those in a bit. When you do the weighted average, that weighted average will end up into one of these bins. So, for example, let's suppose that your weighted average ends up being a 3.87. Let's just say, 3.87 is in this bin, and that would mean that you get an A for the course. And on down. These bins here, by the way, are roughly just indicating which of these, sort of standard grades are you closest to. That's not exact, it's not perfect. There's some variations at the extremes. I'll talk about those in a second. But so, for example, let's talk about this 3.15. 3.15 is the upper bound for a B, and it's the lower bound for a B+. Now, why is that? Well, because 3.15 is halfway in between 3.0 and 3.3. Right, the sort of the defining values of those letter grades. So if you get a 3.16, that falls into this bin. Idea being that 3.16 is closer to 3.3 than it is to 3.0. Okay. All right. So now there's a weird phenomenon in statistics that when you average a bunch of numbers that are sampled from a distribution, the distribution of those averages is not the same. It's a little bit tighter. And so this is most prominent in the extremes. And so you'll notice while you might have expected this number here to be 3.85, it's not, right? It's just 3.80. And that is in recognition of how the averaging, the sort of weird phenomenon with averaging happens. So I've determined these bins by doing analysis of grades, actual student grades from previous semesters and a very large number of students. And my experience is that these bins work very well in determining course grades. Okay. All right. So more stuff down here, and this is just stuff that you need to read. So make sure to read all this stuff. If you're thinking about taking this course on an SU basis, you definitely want to read that section. A few other notices about course grades, things to keep in mind. Okay. So that important topic done. We move on now. And we'll talk about YouTube recordings. So YouTube recordings. Oh, wait a minute. I'm sorry. I got ahead of myself. I talked about course grades, but I didn't get to the specifics for our class. My bad. Let's go back here. Okay, so on the course website, we're just looking at course grades, but now we're going to go back to the class website here. And on my class website, I have some more specifics. By the way, I think we have at least one graduate student. You're going to need to come talk to me as early as you reasonably can. First day class would be good, but anyway, come talk to me. So here you'll see the additional specifics. So I'm choosing the 90% weight for my midterms to break down like this. You'll notice that means that midterm 1 is a little less and midterm 3 is a little more. The idea there is that I don't want anyone to feel too much pressure with that first test, and so anyway. All right, so this kind of it gives you a little bit of a gentler on-ramp into the course. For the 10% that was designated for other, you can see my breakdown here. So the homework will be 7%, attendance will be 3%. There are some further details down here as to exactly how, for example, homework grades are going to be computed. Make sure to read this. It is not going to be the old high school system, 90 to 100 is an A, stuff like that. No, that's arbitrary and not really relevant to what we're doing. So roughly speaking, 100% translates as an A, 4.0, and 65% is going to translate to a 0, and then I'm going to interpolate linearly in between. So notice, for example, that means 82.5, which is halfway between those reference points, is a 2.0. Okay, so one of the big ideas here is that homework is something that you have a tremendous amount of resources for. You can trade ideas with classmates. You can come to office hours and get help. You should, in an ideal world, get it all right. I mean, I understand not everybody will get it exactly right. We all make mistakes. That's of course, right? But you have such tremendous resources there. There is a very high expectation, I'll say, on how well you'll do on the homework. Attendance is another one of these things that a lot of students misunderstand. So again, make sure to read all of these details about percentage. So again, the idea is 100% is an A, 65% is 0, and then interpolated linearly in between. So this tends to sneak up on students because a lot of students tend to think, well, if I just skip one day, it's not that big a deal, or if I skip a couple of days, whatever. But just notice this. If there's 31 lecture days where we count attendance, and if you have an excused absence, well, that excused absent means that we're going to only consider 30. Right? It'll be, effectively there were 30 days for which you were responsible for attending. Notice then that with 3 unexcused absences, you're only at 90% attendance. Now again, don't make the mistake of thinking that 90% is an A. It's not. We're going to interpolate linearly between these 2 reference points. And in this case, 90% interpolated linearly is a B it's right on the border between B and B minus, right? So attendance really matters quite a bit. Roughly speaking, each day brings down your attendance average by about an incidental. That brings you from an A down to an A minus, or an A minus to a B plus, etc. Now, of course, attendance only counts for 3% of your course grade, and you might think that that's not that big a deal, but it really can make a significant difference. Anyway, do keep this in mind. You don't want to throw away, again, every class. This is approximate, of course. It depends on how many class meetings there are, etc. But if every day that you miss unexcused, it costs you more than 1/100 of a point, and that's quite a difference. So anyway, something to keep in mind. Okay, those details being done, we now move along. Let's talk about the YouTube recordings. Again, linked on the class webpage. Here we are again, the class webpage, my section, and down here near the bottom, YouTube recordings. All you got to do is click right there, and here we are at my YouTube channel. The way that I find this a really convenient way to share my class recordings with students. Students are all experts at YouTube anyway, and it's already installed on your phone and your computers, etc. So I just figured it's easy. Everybody wins. I organize things by playlists. So you click on playlists. You're going to notice there is currently no 2024 summer playlist because I have not yet recorded. As of while I record this recording I'm making now will be the first recording for our playlist. So anyway, nevertheless, what you're going to notice, and let me just go back to last summer. You click on that playlist, and you can see that there is going to be a recording here. This is, again, from last summer, this sort of organizational recording. And then every class meeting, there will be a recording. You can just click on it and re-experience the lecture. I think this is a very, very valuable resource. I hope you will make big use of it. You don't have to watch the whole thing again. I'm not expecting most students will, but whatever it is that you were confused about, whatever it was, that was something that I said that sounded important, but you didn't understand it at the time, make a note and listen to it again later. And, pause when you get to a point where you're confused again and ask, wait a minute, what just happened? Why am I confused? Why didn't I understand what he just said there? What was it about what he said that I didn't understand? Leave it paused. Go off and read the lecture notes. Try to figure out what that missing piece might be. And then once you get solidified on what you were previously not getting, then you go back to your paused video. You rewind it a couple of minutes, you listen to it again, and it might just make perfect sense that next time. So this is a resource that I had always, I will say I barely dared to dream when I was an undergrad that I might have something this awesome when I was in college. Let's not talk about how long ago that was, but let's suffice to say YouTube did not exist, and if I missed something that my professor said in class, then too bad, it's gone. So y'all are not in that scenario, but in order to benefit from this, you have to use it. So please do hit these recordings as part of your study process. Listen to things over and over again. Let that be your guide to identifying what you need to study more thoroughly, and etc. Okay. All right. Let's see here. Oh, by the way, I guess I will go ahead and go back to the... Yeah, okay, here we go. Okay, so... yeah, so let's see here. Here's a big topic. This right here. This is huge. Arguably, this is the most important thing in this whole discussion that I'm giving you all now. And that is, I want to make sure we're clear on what this course is about. And yeah, multivariable calculus. Yeah, sure, of course. But what is that? Right? What specifically am I talking about? And very importantly, I'm talking about a collection of ideas that you need to understand, right? That's what math fundamentally is ideas to be understood. Ideas that you can understand and work with by way of valid mathematical reasoning. These are what math is about, and these are certainly what this course is about. So, huge point. Again, most important point of this recording and probably about the course in general is this is what the course is about. It's about ideas and reasoning. So a lot of students make the mistake of thinking, hey, if I get the right answer at the bottom of the page, then I'm good to go, and whatever, however I get there, who cares? Not so. If your reasoning doesn't make sense, then it doesn't really matter what you concluded. If you concluded a result that happens to be correct, but if your reasoning doesn't make any sense, then what the reasoning bore doesn't matter, right? Bad reasoning can't be trusted. So anyway, again, fundamental to the course. So please make sure to digest this. Please make sure that you bear this in mind as you go through the course. Now, you're going to notice very heavily in my lectures, I'm mostly going to be talking about ideas. What is this construction? How does this computational strategy work? Why is this theorem true? That kind of stuff. Right? That's what you need me most for. You don't need me to drill on formulas that are in the book or in the notes. And you don't need me to rehearse you on executing pat algorithms. We will do some of that, right? But that's not what is that y'all are most in need of. Okay, all right. So keep all that in mind. Again, heavily reflected in the lectures. You're going to notice as well on the exams. Again, that's what the course is about. Don't say I didn't warn you. On the exams, there's going to be questions on the exams that get to how well do you understand the relevant ideas and how effectively can you reason, mathematically validly reason with those ideas. Creatively, in ways that you maybe aren't exactly like what we did in class. But again, if you understand the ideas and if you have a good proficiency with mathematical reasoning, then you should be able to use those to solve problems that you haven't seen before. So Yeah, very important. Okay, so you should focus on this through everything as you go throughout the course. So as you're learning the material, you should be thinking about the ideas. Don't think only about remembering the formula. Don't just go straight to the algorithm and say, okay, here's how you do these, and just kind of go through and rehearse processes. Make sure that you are learning the ideas. And make sure that when you're doing homework assignments, make sure that your work explains your ideas, right? And make sure, especially on exams, because they count so much, right? Make sure that your work on exams demonstrates your understanding of key ideas, and make sure that your work on exams shows all of the reasoning that you're using to draw whatever conclusions you claim. Okay, so just to be clear, the way grading works on exams, right? Really big point. Everybody needs to be very aware of this. Points are going to come from reasoning, specifically the validity of your reasoning, the completeness of your reasoning. And I include on this clarity of thought. There's various different versions of what this means, but a student who meanders around and does a bunch of unnecessary calculations irrelevant to the question, and then eventually gets to, the right numerical answer. Well, answers aren't the point. We're not interested in answers. And if your work is meandering and full of unnecessary stuff, then that shows you don't have as important understanding of the ideas. That's what grading is going to be based on, right? And so by contrast, if a student gets to same answer, same result at the end, but gets right to it, right? And the work goes, in the most efficient manner to getting to that answer at the, correct, same answer at the bottom of the page. That shows good understanding of ideas. Again, what we care about in this course. Okay, all right. I also include clarity of written communication. This is unavoidable and also important for other reasons. But I can't give you credit for understanding ideas if you don't communicate effectively your understanding of those ideas. So, in one way, it's just unavoidable that your ability to communicate ideas in writing just has to, I can't get around that fact, right? But also, I want you to keep in mind that being able to communicate mathematical ideas in writing is itself independently a very important skill. And that's what will allow you to use mathematical ideas after this course and after you graduate from college. When you're communicating your ideas to your team or your boss or your research advisor, whatever it is, being able to communicate effectively in writing is just tremendously important. Okay, all right. So again, this is the most important part of what we're talking about today. Make sure to take all of this extremely seriously. This is tremendously important about what this course is. Okay, moving along. So the learning strategy. So this is a subtle one. Every course is set up differently. A lot of high school courses, certainly when I was in high school, were set up as pretty much that the learning would happen in class, and then outside of class, there'd be homework exercises whose purpose was to, polish your skills and execution. But it wasn't really supposed to be for learning so much. The learning would happen in class. The reasonable strategy a lot of students would do is go to class and then go home and do the homework, And then, right before the test, you study for the test, where you basically just kind of, review things, or I don't know, everyone's different. So very importantly, that is not how this course is set up. It is not going to be the case that you will learn primarily in class. There's just not enough time to learn all the material in class. It's a tremendous amount of material in this course. So what I'm going to be doing here is what I think is the best strategy for how to teach a course of this amount of material. And the punchline is a lot of the learning is going to happen outside of class. Now, you'll learn some in class, but a very large amount, and everyone's different, so I can't quantify this, but you should expect that much of your learning is going to come outside of class. So I'm going to spend class time doing what I consider to be the most important, it's hard to say it in words exactly how I decide what to use class time on, but to some extent how important the topics are, how important those particular ideas are as a consideration, but also how much you need an explanation from me also factors in. Tremendously important ideas that you can read on your own. We don't really have to use class time for that because you can just read it on your own. Subtle, confusing ideas that really need a presentation, that really need the opportunity for a back and forth, and a visual aid and this kind of thing. Even if it's not as important, there's more opportunity to gain by talking about that because of just sort of the nature of the material. So anyway, I'm going to be making some tough choices on how to use class time. I will not be able to do everything that I want to do. I just can't. There's not enough contact minutes. It's just not reasonably doable. And so y'all have to fill in the blanks. And it's going to come in the form of studying the lecture notes and studying the book and working in groups, study groups that you'll put together yourselves, and come into office hours with questions and things like this. So a tremendously important point to make sure to understand what I'm expecting y'all will actually do in this course. And I've got a lot of this written up, by the way. I'm going to go back to the course website. You'll notice over here on the right-hand side, there's this whole section called How to Do Well in This Course. Getting right to the point there, right? And so notice the first link here, Learning Expectations. So in particular, I've already given you all this spiel about how ideas and reasoning are what this course is about. And then there's elaboration, quite a bit of elaboration down here on that. Please, very important, make sure to read all this stuff. A lot of really useful ideas in there. And then course design and strategy. And here's the stuff I was just talking about a minute ago. So much material to learn in this course. I have not set it up to maximize the amount that you learn in class time. I have set it up to maximize the amount that you can learn over the entire course. And that means making use of learning outside of class time. And that means giving different kinds of lectures with that strategy in mind. Okay, so again, very important points along these lines. I am going to assume when you come to class that you've already kind of looked over the material for the day. Of course, you never know exactly how far we're going to get on any given day, but preview liberally. Don't try to nail it, right? Always preview a little bit more than you think we're likely to get through, and try to make sure that you definitely understand the prerequisites of those topics, and that you definitely understand sort of the starting point of whatever those pages and notes, whatever those discussions are going to be about. And then try to see the big picture of everything. Now, obviously, you're not going to understand all the details, right? That's, I am going to give a lecture, right? I hope that'll be useful. But you kind of want to know where it's going, roughly. Then, of course, you got to come to class. You got to pay attention and all that good stuff. That's pretty clear, I think. And again, tough choices. Looking for a balance of various considerations. How important are the ideas to the course? How much does it benefit from being actually done in class as opposed to read? And I hate having to make these choices, but it's tough choices that we have to do. And then after class, then you're going to have to look at everything again, this time for hopefully strong understanding of everything, right? You're going to take the ideas that you came into class with, you're going to take the ideas that I throw at you during class and try to bring it all together. I know you're not going to be able to assimilate and digest every single thing that I say in class during class. It's too fast. It's too much, right? So after class is when you're going to sort of put everything together. I, again, encourage that you spend time with the lecture recordings. I think we have an excellent book. So please spend time reading the book's presentations. Again, a little bit of a high cut in some places, and so, keep that in mind. And then again, my lecture notes. I hope you'll find my lecture notes to be useful. Okay. All right. So, you have to do all of this. This is what I'm assuming that you're going to be doing. And if you're not doing what I'm expecting, then the train goes off the rails, and this can lead to big problems. So please make sure to take all of that super seriously. Okay, and let's see here. I've already talked about this point right here. A lot of learning outside of class. For some of you, this might be a first time. For whatever it's worth, I point out, I think many, if not most, technical courses at Duke, if not in most universities, are actually pretty much organized like I'm doing here. In other words, this is not high school. This is not you learn and then you go home and you're done kind of a thing, right? So, but if this is a new experience, not just in preparation for my class, but in preparation for many classes that you're going to take in math or engineering or physics or whatever, you're going to have to adapt to this teaching strategy, learning strategy. And so you might need to make some big changes. Some students will need to make big changes to how they approach a math course with these ideas in mind. Okay, and again, feel free to come talk to me if you're not sure about how to do that. I'd be happy to talk it through with you. Okay, all right. So again, going back to this, so we've talked about all of this stuff. So here are some related suggestions. I found this to be really useful myself, always maintaining a list of questions. And when I say list, I mean a physical, electronic, of course, also fine, but an actual, this is not just in your head, right? This is a manifested actual list of questions, things you don't understand, things I need help with. And if you have an organized actual list, then when you have an opportunity to ask questions, you know what you want to ask. And then when you're done with a given point, when you feel like you have a question sufficiently answered, then you cross it out. And that helps you keep track and you move on to the next thing. So very low tech, high benefit. So I'm a big fan. Next little additional point, make sure that you use all of the course resources. There's a lot of stuff here. My lecture notes we're going to see some of my lecture notes in a couple of minutes here. So my lecture notes are several hundred pages of stuff that, yes, I'll be using them in lectures, but you can also just read them. And I hope you all will find that to be a useful resource. Old exams. I don't even know, probably hundreds of old midterm exams available online for you all to look at. I hope you'll find those useful. I think it's a good way to check your understanding of material. You can see some actual old exams from past semesters. Unfortunately, we do not have a help room this term, but we do have a TA who's going to have office hours. So anyway, sadly, no help room for us. But also, take a look at the ARC, right, Academic Resource Center. They have good stuff. In particular, I want to point out ARC has a program called Study Connect. Excellent program. Roughly speaking, it'll hook you up with other students and help you form a study group. Even if you don't know anyone in the class, it'll connect you with like-minded, interested parties. And then don't forget about office hours. And sadly, there are no other instructors. But there is a TA that I expect will be holding office hours, and those details are TBD. Okay. So we've already talked about study group. I'm a big fan. Roughly speaking, this is what I think is the big trick, the useful thing for a study group. Don't just divvy up the homework and, well, of course, that'd be cheating. But try to get a discussion going. Try to trade ideas. What I used to do when I was in college would be to take some idea that I thought I understood and just, get all my friends' attention. Say, okay, here it is, guys. I propose for discussion that blah, 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 and I would have some assertion that I would make about, all integrals can be computed by blah, 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 whatever. And then sit back and await comments. And some people might say, yeah, I think that's right. Or other my friends might say, I can see why you'd think that. But in fact, I think here's a counterexample. And then someone else would say, you know what, that's not actually a counterexample. And here's why I think that actually, whatever. And you get a dialogue going, and it's just a fantastic way to hone in on the point. Right? You can take the combined understanding of everyone in the group and just hone right in on, hopefully, points that somebody misunderstood. So I am a big fan. I hope you all will consider doing something along those lines yourself. Okay. Let's see here. Last item on the list, and then I am going to go back and make some specific notes on these two things, I guess. So the homework. A lot of people make the mistake of thinking of the homework as an assessment, as being part of your grade. And it is part of your grade, I suppose, and yeah, you have to take it seriously in that sense. Okay, but that's not why we have homework. Homework is not primarily intended as a way of gauging you. We make the homework count as part of your grade to make sure you do it. Right? But the main purpose of homework is to learn. It's part of the learning experience. So as you're doing that, as you are having this learning experience, think in terms of how what you're doing will help you prepare for exams, which really are assessments, and they really are very big contributions to your course grade. So even though you might be able to get away with, being sloppy, perhaps, on, showing your work, explaining your reasoning on homework, that's not a win. Don't think of this as, what's the least that I have to do to get those points? Instead, think, what is the most that I can do to communicate what I understand? Because that's what you're going to have to do on the exams. Right? So try to do a great job on the homework. Try to do more than the grader will expect of you. And again, use this as a valuable opportunity to practice explaining your reasoning. Okay. All right, so we're making good progress here. I do want to go in and talk about the lecture notes. Here is an example of my lecture notes from Chapter 1. And I'll show you. In fact, why don't I show you where to find these on the class website? You notice there's a section here called Class Materials. Click right there on Class Materials, and here it is. It's this file right here called Math 219 Bray Chapter1.pdf. You click on there, and the file just downloads. You'll notice similarly for through Chapter 7. I'm also going to have a little introductory spiel I'll be giving, and this diagram is something that I'll be using later in the course. We'll look at that right now. And this document called Organizational Notes. Actually, I see now this is the one that's out of date. I'll be updating this file. This is old. If I forget to do that, please remind me. But I'm going to plan to do that as soon as I'm done making this recording. Okay, so that's where the notes come from, and during class I'm going to be annotating to draw focus. So for example, here this business about how to add vectors and the resulting theorem called the triangle inequality. I'll do stuff like this and point out that this vector A and this vector B, and we can talk about their sum and the sum there. Notice that these three vectors and their sum make a triangle, and thus the name triangle inequality. And then, etc. Discussion to be had. So I'm a huge fan of this way to use colors in particular to link algebra with geometry, like I just did there. And anyway, that's how the lectures are going to go down. And so expect a lot of that. I'm going to point out that, and this is a nice example right here, sometimes you're going to find yourself with questions. And this point that I have, this example right here, is actually somewhat subtle and a little bit of a challenging idea for people to digest. And we'll talk about this in class, of course. But in class, if you find yourself not clear on something that I talk about, you can make a note. So, for example, right here, I'm in a weird mode there. Let's see here. So, right here, for example, right next to what you're having difficulty with, you can just look down here and you see right now as I record this, it's 5:08, and in our classroom there will be a clock, I hope. If not, of course, you have your phone or your watch or what have you, and you can just write down, okay, 5:08, right? And then when you write that down in your copy of the notes, and then when you get home after the lecture or back to your room and you wait, okay, where in the record, where was that, he was talking about this thing, and where in the recording would I find that discussion? Well, you've made a note, and then you can just click through the recording. This time will be visible, right? And you can just click through or you can extrapolate from the start time or whatever, and you can just click right to where the discussion is that you wanted to re-listen. So I think this is a really nice little organizational trick. Just annotate the time as a very convenient way for getting, keeping track of what you want to listen to again. And I suppose you could even put the date, right? And let's see, this is May 13th. So you could do something like that. But anyway, okay. All right, and then let's see, the last thing I wanted to talk about, right, so my old exams. So my old exams, you're going to find those on the website as well. That is, let's see here, it's on the course website, and there's this section called Course Resources. In Course Resources, there's actually quite a few resources listed, if only for effect. While we're here, I'm going to point out, you are your own primary resource for learning in this class. All right, and this is my way to emphasize that you are the one that's going to have to make it happen, right? I can talk about math all day long, but I can't make you watch the recordings. I can't make you focus on things. I can't make you come to office hours. I can't make you ask questions. I can't make you think creatively and think aggressively on making sure that you're understanding the ideas. So you are your own primary resource in learning. And then various other things, and again, this is all important. Make sure to read all this stuff. But I like to come down to this section right here. Item 7, and this is where I have this massive cache of all of my old midterm exams. Now, the Math 219 list is not huge. I've only been teaching Math 219 for a couple of years now because it's only existed for a couple of years. Nevertheless, that's a pretty useful old list of old exams. But Math 212, not the same course, but a very similar course, in fact, with very few differences. The linear algebra prereqs, the only difference. This list of old Math 212 exams is quite massive. You can see I've been teaching Math 212 since 2004 here at Duke. So enormous cache of old midterm exams, all of which is relevant to what we're doing in this course here. And again, maybe not exactly the same, and maybe slightly different approaches because of the linear algebra prereq, etc. But still, a lot of useful stuff. Then thirdly, I have a different folder for my midterm exams from when I used to teach summer classes of Math 212, and I did so out of my own textbook. So I have my own textbook that I wrote 15 years ago, I guess at this point. And back when I was teaching Math 212, I wrote the book for that audience with those prerequisites and everything. So that made sense at the time. And so anyway, slightly different. So a different folder. And one of the things that I did differently in these old summer offerings of Math 212 is I included some linear algebra. So in fact, these are arguably more like Math 219 than the others. So anyway, all useful. I hope you'll find those to be useful for you. Okay, so I think we are done. So let's see here. I'm sure there's a million other things that we'll need to talk about eventually, and I'll be sending emails and such. But until then, let's go ahead and call it a day. I look forward to meeting y'all on Wednesday, and I look forward to working with you in this course in this first half of the summer. Okay, see you soon. Bye-bye.